So hello guys, welcome back to another video, and in today's video we'll be solving the question unique paths 2. So before attempting this question, I would request you to go and see the unique paths 1. We have already solved the unique paths 1 and it's almost the same problem, but just the only thing here changed is the obstacle thing, like this thing. Okay, so this thing is, wait a second, I'll just tell you. Yeah. So it's the same problem. Basically now one thing is included more is basically the obstacle. So to handle this obstacle, we have to just make another condition uh, to handle this obstacle, right? So I'll just explain you the question. For example, if we have to reach here, okay, so the way is here. We can go from here, then here, right? And we can also go from here, and here. So as you can see, the transition, if these are n rows, like these are n rows from 1 to n, and these are m rows, m columns. So the transition here is what? It's n minus 1 plus m, right? And here it's n plus m minus 1. Now the only thing here is we have to check the condition for this obstacle, and this obstacle in the question is given in the obstacle grid, it's given as 1. Okay, so basically we'll just handle it by, we'll place 0 there in our dp grid because we can't go from this path, right? So we'll just handle this in the code itself. So I'll just show you the code. Yeah. So first of all, we'll define n comma m, which is equals to length of obstacle. One second. Yeah. Now we'll make a dp grid, which is the dp state, and which will be dp equals to 0 into m columns for underscore in range n rows. Now for range in range m, and for j in range m, basically if I is less than 0 or j is less than 0, then dp of I and j equals to 0, right? And L if obstacle CLE and GRID grid I and j equals to 1, then in our dp grid we'll just change a dp, we'll assign 0 there, right? Now one more condition, which is L if I equals to 0, and if I and j are both on the starting point, then we uh, just have one way to start, right? From the starting point we actually have only the one way, so we'll assign 1 there, right? And now else, which will be coming from up, the changes in the rows, which will be I minus 1 and j, and the condition here will be if I is greater than 0, only then, else it would be 0, and when we are coming to left, then it will be dp of I and j minus 1, and if j is j is less than 0, guys. This should be no, yeah. If j is greater than 0, and if j is greater than 0, then if it's not, then it would be 0, and our dp would transition would be we'll just add up both the guys, up plus left, and now we'll return our dp, which is m minus 1 and m minus 1. I think it's okay. We got a wrong answer. Let me just see why. Okay, for I in range n, if we are in that row, and yeah, this is correct. Uh, okay. Come on. Oof. Like, seriously. Uh, how could I forget this return? Oh my god. Yeah, guys, so this was the DP solution for it, for this problem, and it was pretty easy. Like, what we did here is basically, here what are we doing is we are just like, if out of bounds, then no way. So dp equals to 0, right? And if there is an obstacle here, if there is an obstacle, then assign 0 again. Okay, and if we are on the starting position, then there is only one way, right? From the starting, like, if we are here, uh, to come here, there is only one position. It's not about going here or here. Basically, when you are starting, when you are just put onto the grid, you will mark it as one, right? Because that's the starting point. And then up and left, the thing I explained you, if you go to the target, you are coming from two transition. There are two state transition. One is I minus one and j minus one, the rows and columns, and then you'll return this. Now for this question, we can also solve it using recursion. Basically, it's more of memorization. I'll just show you. Define paths I comma j, and yeah, if I is less than 0 or j is less than 0, then return 0. If uh, I equals to 1 and j equals to 1, oh, then return 1. If I and equals to 1, then also we return 0, right? Is there any condition which you are missing now? The out of bound is satisfied and the starting is done. This is also done. Now return paths from I minus 1 comma j plus n minus 1 comma n minus 1. I will just check this thing. Yeah, so it works. So it might give you a TLE right now. Let me just check. Yeah, it should give a TLE because it's a recursive solution. Now, for to make it work, what we'll do is we'll use the technique memoization. But instead of creating the dictionary manually, what we'll do is, okay, we got a wrong answer here. Maybe just mm, and we are okay. I think we are missing a case here. If I is 0, and why are we getting a wrong answer here? It's in store grid 1. Output should be 1 and output is 1 and expected is 0. Let me check here. Yeah. And oh, how could I do this wrong? Uh, the conditions are if I is less than 0 or j is less than 0, then of course we return 0, and if obstacle grade is equals to 1, then we return 0 again, and if I equals to 0 and j equals to 0, then return 1, right? Yeah, but n minus 1 and n minus 1, and so first we are defining what? First we are defining the column, and then we are defining the rows, right? Let's just see. Again, it's giving a wrong answer. Yeah, so guys, basically we are getting the wrong answer. It's it's because of the order. And to be honest, I also didn't knew that, and I just didn't focus on that. This is the beauty of this question. Basically, what when I submit this code, we'll get a wrong answer. Why? Because of the order. Like first we have to check because uh, wait a second. Yeah, first we have to check like this condition if yeah it's and it's failing on this condition if I and j equals to 1, right? 0 0. So on 0 0 we already made 1 and then we are returning 0 again, right? So our output is 1 and we are expected to give 0, right? So basically this thing, now it would probably give you a TLE, and for TLE what we'll do is we'll use this thing, which is LRU underscore cache. It basically creates an automated dictionary for you, automatic memoization. So probably now it will get accepted. Yeah. So guys, this was it. This was it, and you should try this question. It's actually a good question. And yeah, thank you so much.